All right, this is attempt number 2. And in the interest of full transparency, I went and looked on the forums about how to solve this problem because I was not able to solve this problem on my own. And it gave me an idea, and you will see the idea, and I hope it works, and I'm not happy about it. One, I'm not happy that I had to look it up, but two, I'm not actually happy with what the idea is. And so this is what it said. So we are going to make our own thing, which is day 23. I'll just call this scratch. Okay, so what the hint I found online said was, and I went in and previously I added these comments to my input file. So like when this says if A is not 0, jump 2, that just says to line 5. If 1, so if true, basically go to line 5. Jump 5, so go to line 9. So I just basically added in what those offsets are. So the advice I found was basically to go through in our head and rewrite what this problem does until we get to something kind of sensible. So why am I not happy about that? One, because it's a little bit at odds with kind of how the previous advent of code stuff worked. And two, because it suggested that there's something very specific about this program that makes it amenable to that kind of treatment, whereas most programs that are written in this little mini programming language would not be amenable to solving this way. And so that's what I don't like about it, is that here's a solution that really only works because of a very specific thing that they gave us. And so I played around with this a little bit before, but I didn't quite finish it. And so we're just going to sort of rewrite this. And so we're going to start with all these jumps. So this jump says, look at G, and if G is not 0, skip ahead to line 17. Otherwise, go through here. And so what that really means is if G is not 0, set F to 0. If G equals 0. So if G equals 0, then we don't do the jump, so we set F to 0, and then we go to the next line. Otherwise, don't do anything. And we never jump into the middle here, so we can get rid of lines kind of with impunity. So we can say get rid of that and get rid of that. So we've basically rewritten lines 15 and 16 to say if G equals 0, F equals 0. And now we can look at a couple of these and just rewrite what these are. Subtract GB means G equals G minus B. Multiply G E means G equals G times E, and set G equals to D is G equals D. And then we jump once to line 12, but we never jump to any of these other lines. So we can just say G equals D times E minus B and get rid of these two lines. Okay? And now let's look at these and say subtract from E minus 1, so E equals E plus 1. Set G equals E. And subtract off GB, so G equals G minus B. And then I can just combine these two again. G equals E minus B. So did I do that one right? G equals E minus B. Yeah. Okay, so now to line 12. So let's look at this bunch here. So if G is not 0, then we go back here. So this is really while G is not 0, well, let's just say this is while true, and then if G is if G is 0, then breakout. Okay, and G is really E minus B here, so this is just if E equals B, break, and then we can actually get rid of this as well. And I happen to know that G kind of gets set wherever it's needed, so I'm just going to delete that. And now G equals D minus E plus B. So if G equals 0 is really if D times E equals B, set F equals 0, E equals E plus 1, if E equals B, break. Okay, and so now, at 11 we say set E equal to 2, right? So what this really means is, and let me put this down a little bit, and because I want to jump to 11, I'm going to leave a dot there. So E equals 2, and then I do this loop. If D times E equals B, F equals 0, E equals E plus 1, if E equals B, break. So what this is really saying is for E equals 2 to B minus 1, if D times E equals B, set F equals 0, and that's it. Okay, and so now what is this saying? For E equals B, so we're looking at every E and saying for whatever D equals, can we multiply it by something and get B? So in other words, if B is divisible by D, set F equal to 0. Okay, so and so that's basically, we can say at line 11 is doing that. Okay, so now we have this group of things which goes back to line 11. So again, we can say D equals, subtract off D minus 1, so that means D equals D plus 1. G equals D, G equals G minus B, and if G not equal to 0, go to 11. Okay, and so now again, what are we doing? We start with D equals 2. So if G equals 0 is saying, so these two we can combine again. G equals D minus B. So this is just saying if D is not equal to B, go to 11. Okay, so now we're just saying start with D equals 2. If B is divisible by D, F equals 0. D equals D plus 1, and then just keep going until we get all the way up to it. So again, this is actually a for loop, right? For D equals 2 to B minus 1. And then we can get rid of this. If B is divisible by D, F equals 0. And that's it. Okay? So we're basically saying f is 1, and then if there's some number d which divides b, set f equals 0. Okay, so if b is a prime number, then there will be no such thing that divides it. And so f will stay 1. And if b is not a prime number, then f will be 0. So now we're saying if b is prime, f equals 1, else f equals 0. Okay? So it's also the case, so let's rewrite some of these. B equals 57, C equals 57. And now we're dealing with our second case where we said A is definitely going to be 1. So A being 1 means that we just go straight to line 5, and so we skip over this one, so it's done. Multiply B by 100, so that means that B equals 5,700. We want to add 100,000 to B, so that's saying B equals 105,700. And then we want to set C to B, so C equals 105,700, and then subtract off C minus 17,000, so we add 17,000, so C equals 122,700. Okay, so now if f is 0, then we skip that, right? So let's just stick this all in. So if f is 0, and we want to say h minus equals 1, so that's fine. And now we want to set g equals b. So g equals b minus c. And then if g is not equal to 0, go to 31. Otherwise, we go to this thing which is finished. So I'm just going to rewrite this as if g equals 0, exit. And then otherwise, b equals b plus 17. And then we want to go to line 9, which is here. And so, you know, this is basically while b is not equal to c. So basically, what this program does is, assuming we did it right, is the following. And we don't even need these f's now. If b is not prime, if b is prime, do nothing. So if b is not prime, h, and I think that should be h equals h plus 1. I'm being sloppy here. Don't need that. Let's just make sure. We wanted to subtract off h minus 1, so that's actually adding 1 to h. And now, I just make sure that I'm counting composites rather than primes. So f starts as 1, and then, you know, if we found a divisor, we set f to 0, and then if f is 0, then we add 1. So we're counting composites again. Okay. So now, and let me rename this day 23 conflagration 2.py. So we'll make this a Python file now. And I think H starts at 0. And so, well, B is not, and so what we need is an is prime function, and we'll just write a really bad one. So we have some int and it returns a bool, and x is prime if for divisor in range 2 import math math dot square root of x, and we need to int that. If x mod divisor equals 0, return false, otherwise return true. So this is not the most efficient is prime, but I think it works. Math is prime 23, true is prime 24, false is prime 25. Okay, so it doesn't work because I need to go up to 1 more than this. So let's try that again. That's why we write tests. 26, 29, 36. Let's try 49 is false. 41 is true. Okay. So, well, B is not C. If not is prime B, and then let's print H. So, let's see what happens if we do this. Invalid syntax. Okay, so run day 23 configuration 2.py. It's saying 914. There's only 914 composites if we skip by 17. And so let me just check one thing. So there's 1,000 numbers in there, and of those 1,000, 914 are composites. So that seems mostly right. So let's try that. That is not the right answer. Answer is too low. Okay, well, let us try. Let's try doing this one more time. Scratch.md. Okay, so let's just start this time by b equals 57. Set C B. So C equals B. Here we know that A equals 1, so we want to go to 5. So just delete this. B equals B times 100. B equal B plus that. C equals B. C equals C plus 17,000. F equals 1. D equals 2. And let's make sure that's at line 8. It's not. So I'm going to run into trouble already. D equals 2 should be line 10. Equals 2. G equals D. So let me give these numbers 10, 11, 12, 13. G equals G times E. 14, G equals G minus B. 15. And let me just make sure that I got these bounds correct, because maybe I screwed that part up. That'd be the easy part to screw up. B, 105, 700, 122, 700. 105, 700, 122, 700. So that part is right. And F equals 0. E equals E plus 1. G equals E. G equals G minus B. So let's say if G is not equal to 0, and let's make sure that only if the value of x is not 0. So if G is not equal to 0, go to 17. If G is not equal to 0, go to 12, 21, D equals D plus 1, 22, G equals D, 23, G equals G minus B, 24, if G is not equal to 0, go to 11, 5, if F is not equal to 0, go to 27, H equals H plus 1, 27, G equals B, 28, G equals C, 29, if G is not equal to 0, go to 31, 30, finish, 31, B equals B plus 17, and 32, go to 9. Okay. And what was 9? 9 was set F equal to 1. So let me do that. Okay. So now, again, if G is not equal to 0, F equals 0. So we can get rid of that. G equals E. G equals E minus B. And so if E is not equal to B, go to 12. So that's fine. And so we have this little loop here, which is basically, and again, I'll put these dots in here. And so this is really for E equals 2 to B minus 1. And these are just G equals D times E minus B. if G is not equal to 0, F equals 0. So that's if G times E is not equal to B. F equals 0. And that feels wrong. Did I get that one wrong? Fuck. All right, let's try this one more time. Because I screwed it up once again. Okay, so B equals 57. C equals B. Definitely do this. B equals B times 100. B equals B plus 100,000. C equals B. C equals C plus 17,000. F equals 1. D equals 2. E equals 2. Let me make sure that that's right. 11 equals 2. Yep. G equals D. G equals G times E. G equals G minus B. If G is not equal to 0, go to 17. F equals 0. E equals E plus 1. G equals E. G equals G minus B. If G is not equal to 0, go to 12. D equals D plus 1. G equals D. G equals G minus B. If G is not equal to 0, go to 11. If F is not equal to 0, go to 27. H equals H plus 1. Set G B. So G equals B. G equals G minus C. If G is not equal to 0, go to 31. 30, jump 3, so done. 31, B equals B plus 17, and 32, go to 9. Okay, so let's see if we can do this without messing it up. And so 9 is what we're going to loop over. So that part is all set up. And I can just take these numbers off now. Okay, so to start with, if G is not equal to 0, go to 31. So let's rewrite this as if G equals 0, break. And then otherwise, B equals B plus 17, and then we want to go to 9, so at 9, let's just stick a while true. Now we're done with that. G equals B minus C, so we can do that one as well. And so this is really just if B equals C, break. Okay, and So now we don't really need, now we can change this to say if f is not 0, go there. So that means if f equals 0, h equals h plus 1. And now we can get rid of those as well. So now let's deal with a couple of these loops. Here g equals d times e minus b, so I can get rid of those. And this is really if d times e is not equal to b, go to 17. So that means that if d times e is b, set f equals 0. And then I actually don't need this. And then g equals e minus b, so I can wipe that out. And if g is not equal to 0 is saying if e is not equal to b, go to 12, which means if e equals b, break. And that's, again, a while true, which I'll do in here. And then this is really just a for e equals 2 to b minus 1. And I can do that. If e equals b, break, d equals d plus 1, g equals d, g equals g minus b, so that's just g equals d minus b. If g is not equal to 0, go to 11. So that's again saying if d equals b, break. If g is not equal to 0. So we've added d, and then we go back to this again. So this is another while true. And then if d equals b, break. And so this is really just for d equals 2 to b minus 1. And so then this is really, for I don't need this either. So for x equals, b to c, by 17. And then, like we said before, we're basically saying for every d up to b minus 1, for every e, if we ever find a pair that work out, we set f to 0, otherwise f is 1. And so we add 1 if it's composite, and then we break when we get there. So I really feel like I did this correctly. There's b, there's c. For x in range BC 17, total equals 0 for x in range B, C, 17. If is prime x, total plus equals 1. Total is 80, total equals 0. If not is prime x, total is 914. So that seems right. For x in range, 2 to 100, print x is prime x. I wonder if there's a bug in this. Is prime function. 2, 3, 5 is true, 7 is true, 11 is true, 13 is true, 17, 19, 23, 29, 31. So that looks right. But meanwhile, my 914, it did not like that answer. So why did it not like that answer? It did not like that answer. Do I have an off by 1? Like if I put 915 in, is that right? That is the right answer. So somehow I screwed up the boundary condition. Like I guess I should have included the C, but I didn't. I guess. I don't know. Anyway, I hate this problem, and hopefully you hate it with me. And that was another 40 minutes, which was awful. All right. I hope tomorrow's problem is not like this, because this one sucked. All right. Thanks for watching. And what's me on Twitter? I don't know if you want to follow me after this, but maybe you do.